In 5.3 we'll look at comparing and ordering fractions. Now there's really two different ways that you can go about this. When you look at these types of problems, these end up being really easy to do because your denominators are all the same. So when you have that, all you simply have to do is look at your numerator and see which one is smaller. So if I'm doing least to greatest, I know that 3 is going to be my smallest, 3/8. When you follow your order, you have 5/8 would fall next, 6/8, and then 8/8 would be your greatest. Now it becomes a little bit tricky here when you have different numbers for your denominators, because now you're looking at a shape that has so many different sizes of pieces in it. But when you have the numerators that are all the same, you should be able to look at this and say, I know a circle that has 12 pieces in it is going to be really small. So that's probably going to end up being, if there's only 2 pieces out of that, that's going to be really small. When I look at these things too, well, the 2/7 and 2/9, I'm not quite sure which one I would look at there. So the other thing that you can do is try to find an equivalent fraction. So one way that you could do that is look at 7 and 9. And you've done factors and multiples and things like that before. So I know that if I look at those two numbers and I say I know I have 7, 14, 21, 28, all of my multiples in there, 9, 18, 27, 36, and we could go on and on and on. And we got to find that multiple where they have the same one. In this case, one that we'll look at is 63. So an easy way to compare the 2/7 and 2/9 equals 63 as my denominator, 2/9, 63 as my denominator. So I'm trying to find an equivalent fraction for these two. I know that 7 times 9 would be 63, and I got to do the exact same thing up on top. So that ends up being 18 over 63. When I multiply here, I know it's 9 times 7. I have to do the same thing up top, and that's 14. So by looking at these with the same denominators now, I know that 2/7 is probably going to be bigger, no doubt, than 2/9 because my new numerators here, you can compare the both of those. So there's another example of being able to compare fractions and order them by finding an equivalent fraction, as you can see there.